So implicit differentiation, and we've gone through the rules of implicit differentiation, and this is the question we'll be working on. If you haven't already done so, please pause and try. Okay, what do we do? The first thing we do is d by dx of both sides. On the right hand side it's just 0, so you'd normally obviously write this down on a separate line. You take d by dx of both sides. Now here, to the power of a half, isn't it, the square root? So it's, I won't be completely lazy. I'll write it out. And now immediately we encounter a product. So we differentiate product in the usual way using the product rule. So we take d by dx of each term, and the first term is a product of x and y, or here x to the half, y to the half. But we use the usual rule of differentiating the product. It's u, the first one, and v is the second one. Okay, so it's u dv by dx. So it's x to the power of a half dv by dx. Now here we have to be careful. We are differentiating y with respect to x. So we differentiate it with respect to y, and then we put a dy by dx for reasons we've already gone through. So I'll just put that in brackets. Differentiating y to the half with respect to y gives me a half y to the minus a half dy dx. So now we've done u dv by dx plus v du by dx. V is just y to the half, and du by dx is half x to the minus a half. Okay, so we've now differentiated that term. This is very straightforward. The derivative of x with respect to x is simply 1. And the derivative of y squared with respect to x, again, we follow the usual rule of implicit differentiation, and we've gone through that. So we first differentiate it with respect to y. So it's 2y dy dx. Then we put dy by dx next to it. And I won't go into the details. We've already explained that. And that is equal to 0. And now we want to find dy by dx. Should have actually mentioned that at the beginning. The objective is to get dy dx. So here we have dy by dx. I can now, if you like, factor out dy dx. So I'll do that now. And what I'm left with is x to the power of a half. We can write that as root x over, because y to the minus a half is 1 over the square root of y. So it's over 2 root y plus 2y dy dx is equal to, now if I take all the other terms to the other side of the equation, it's minus, again, if I apply my laws of indices, then y to the half is simply the square root of y, and x to the minus a half is the square root of x, or 1 over the square root of x rather. So that's that term dealt with, and then minus 1. Now here is just a case of simple algebraic manipulation, so we can do that. The right hand side, if I want, I can combine the fraction. Similarly, I can do that on the left hand side. Okay, so I'll do that slowly. If I combine the fraction, I have root x plus 4y to the 3/2, y times root y, all over 2 root y, dy dx is equal to, I can do the same thing to this, minus root y minus 2 root x all over 2 root x. Multiplying the left hand side by 2 root y, taking it over to the right hand side, you can see that the 2's cancel out, and then dividing through by this. So I end up with, now I can leave the algebra to you, because I want to do this in one step. dy by dx is equal to root y bracket minus root y minus 2 root x all over root x bracket root x plus 4y to the 3/2. If that was too fast, what I'd like you to do is pause the video and check the working out yourself. Now, depending on the situation, you wouldn't need to simplify it as long as you've got dy by dx. But just for the sake of it, let us now simplify this even further to make it look nicer. So dy by dx is equal to, multiplying out the top by root y, we get minus y minus 2 root x y all over, multiplying the bottom by root x, removing the bracket, we get x plus 4 root y cubed x. And that looks as nice as it can be, I suppose, and that's the final answer.